Math is the best. Math is the best. Math is life. Mr. Ang, the best teacher in the West. We're so blessed.
Hey guys, let's go over quiz number 2. This is version B. You guys had this kind of similar problem in the last quiz. Classify each of the following according to its degree and leading coefficient. This one wants to have an even degree. Evens have their arrows in the same direction, like they use this one here, x squared. And then a leading coefficient that's negative basically is going to flip it over on the x-axis. So I'm going to look for a graph on A, B, and C that does that. Okay, if you put a coordinate plane on that, just a quick sketch, you'll notice on the y-axis they're both facing down, which is both negative infinity. And the only one that has that is A. Okay, B has an odd degree, so x to the first is the easiest, and a positive, so it's going to stay there. So now I'm looking at choices G, H, and I. And the only one that has it in quadrants 1 and 3 is choice H. H is our answer. Okay, which graph shows odd symmetry? Odd symmetry is, my phrase is, that's odd. It's the opposite, or the origin. It's symmetrical about the origin. Some people also call this corner to corner. So these two corners here are not matching on A, B, C. That's a tree, mountain. But look at this one, has both a mountain and a mountain. Symmetry is symmetrical 180 degrees, either clockwise or counterclockwise. So I have a tree, or mountain, mountain, tree, tree, right? So if I rotate it this way, it would be like over here, and then I rotate it again this way, then it would look just like this one. This one, if choice B is wrong, because if it was actually exactly going through the point of origin, that would probably help. A is way off, and C, if they had positioned it, no, it's not. So our answer is D is your correct answer. All right, let's go to the back side. Use the characteristics to draw it on this coordinate plane. Let's go ahead and draw this. Okay, even degree. So x to the second. Put them in the corners. Positive a value. That means it's not going to. It's going to stay. I'm going to write the word stay. They're not going to be reflected over the x-axis. They're not both in quadrants 3 and 4. Okay, 6 x-intercepts. Now here you can choose either the shoot-throughs or you can do the kisses. You can kind of choose. Remember, shoot-throughs are worth 1 and kisses or bounces are worth 2, so you can kind of just choose. I'm going to count these as kisses. I'm going to write a K. And that's just going to remind me that they're going to bounce at those locations. I don't know if it's possible. Let's see. Okay. Absolute maximum at 1. Okay. Now I'm running into some problems here. Okay. Absolute means the absolute highest mountain or roller coaster. And how is that possible if my arrows are in the air up there? And relative minimum at -4. All right, let's try drawing this. See what happens. I like to go left to right. But I want you to notice that I'm starting up here in the top left. And already that is something higher. But at the red line, we were supposed to do a highest point, like right there, right? Does this make sense? Okay, I wanted to bounce. Maybe so I have to change it not to be a kiss. So let's say it's something like this. Let's say those are shoot-throughs. So that also means it wanted a lower point than that. Maybe I have to do another shoot-through. Okay, so the big one I think is the absolute maximum at -1. So I'm going to write this graph is not possible, comma, because this is our great explanation word. We have a relative or a local max at y equals 1. Cannot be absolute. Right, because we're saying at this point right here, the red dot, that has to be the highest mountain or part of the roller coaster, and that's not true because the roller coaster goes higher than that. Okay, number 5. Okay, the first thing I notice is the degree, x to the first. So this is an odd degree, right? So let's check. This is an odd degree. Okay, that matches. Let's count. 1, 2, 3, 4. This is x to the 4th. That is bad, so I'm not going to choose that one. Okay, this is also odd, which is good. Okay, so I have the first and the third one. Okay, the next thing is just this is a positive and this is a negative. This is going to be a positive because the arrows don't change, so I'm going to keep the first one. I eliminated the second one because this graph would look something like that. Let's just write the sentences based off the colors. Chose first polynomial because it is an odd degree and a positive leading coefficient. Guess that last part should be in green there, because that's what I annotated. Okay, why? You don't need to have both of these, but why did I eliminate? I eliminated because the others have one characteristic. Odd degree or a positive leading coefficient, but not both. Okay, hope that was helpful for you guys. See ya.
Oh no, what happened?
Mario didn't show his work and he got a 0.
Oh no, Mario, you must show your work. It's a point for you and for Mr. Ing to see. Whoa, I think he's actually showing his work. Yay!
Yay, good job, Mario.
And remember to always show your work.